Hey everyone, welcome to this explainer. I am absolutely thrilled you're tuning in today because honestly, we are right in the middle of a massive shift in the world of artificial intelligence. We're finally moving away from those simple, stateless chatbots that kind of just sit there waiting to answer a question, and we're stepping into the era of complex, multi-agent AI workforces. We are talking about digital systems that can actually plan, remember, collaborate, and execute really complex workflows entirely on their own. It's a fascinating evolution. Just take a second to let the weight of that shift sink in. We're literally moving from using tools to managing teammates. I can't wait to unpack exactly how this new architecture works.
But before we get too deep into that multi-agent future, we've got to address a glaring problem. What happens when your brilliant AI agent formulates a flawless multi-step plan, executes step 1 perfectly, moves to step 2, and then completely forgets the results from step 1? Just imagine asking an AI to research a target company, summarize its quarterly financials, and then draft an introductory email pitch to their CEO. By the time it gets to writing that email, it's completely forgotten the name of the company it just researched. It's like working with a brilliant genius who happens to have profound short-term memory loss. And that is the core limitation of traditional, stateless large language models. They have a fixed context window that constantly gets wiped clean. So to build truly persistent AI workers, we have to solve this memory problem.
So here's our roadmap for the explainer today. First, from chatbots to agents. Second, building the AI memory. Third, the multi-agent workforce. Fourth, frameworks and performance trade-offs. And finally, securing autonomous AI agents. Let's get right to it.
Section 1. From chatbots to agents, the evolution of the individual contributor.
This first part is all about the evolution of the individual contributor in our digital workforce. We are fundamentally shifting from interfaces that just sit around waiting for our prompts to active problem solvers that actually go out and get things done. To really understand this shift, we need a solid definition. An AI agent is a software program capable of perceiving its environment, making decisions, and taking autonomous actions by interacting with external tools to achieve specific goals. And the absolutely crucial word there is tools. You see, when you give an AI the ability to search the web, execute code, or query a live database, you fundamentally change it. It goes from being a static answering machine into a digital employee. Think about what this means for your daily workflows. A chatbot just gives you a recipe, right? But an agentic digital employee checks your fridge, figures out what's missing, orders the groceries, and schedules the delivery. It has actual agency.
Moving on to Section 2. Building the AI memory. Solving the context window limitation.
As we established a minute ago, giving an agent tools really isn't enough if it just forgets what it's doing halfway through a task. To be a true partner, our digital worker needs a long-term memory so it can escape that fixed context window trap. Okay, let's dive into this process, because the engineering behind it is just brilliant. AI doesn't remember things the way you or I do. It uses vector databases. Don't think of this like a traditional alphabetical search, but rather as a massive semantic filing cabinet based entirely on concepts. Step 1, we ingest and embed text, like a user's preference or a past action, into numerical vectors. We map its underlying semantic meaning. Step 2, we store those vectors in a database. Step 3, when the agent faces a new task, we query that database to find mathematically similar vectors. And step 4, we retrieve that relevant past information and inject it directly into the agent's active context window. So it doesn't biologically remember. It contextually retrieves exactly what it needs, exactly when it needs it.
Section 3. The multi-agent workforce. Scaling from individuals to departments.
Now that we've got individual agents that can actually use tools and remember their past actions, it is time to scale up. We're transitioning from the micromechanics of a single agent's brain to the macro orchestration of an entire team. And you might be wondering, why do we even need multiple agents? Well, if you try to build a monolith agent, one massive AI trying to do absolutely everything, it gets bloated incredibly fast. Its context window overflows with totally unrelated instructions, it loses focus, and honestly becomes wildly expensive to run. It's a classic jack of all trades and master of none. Conversely, a multi-agent system operates much more like a real human company. You have specialized, isolated agents focused strictly on specific domains. It is just far more efficient and composable to hire a team of dedicated specialists than it is to force one stressed-out digital employee to do every single job in the entire building.
But how do these specialized digital employees actually work together? There are 3 main orchestration patterns you really need to know about. First up is peer-to-peer delegation, where one agent calls another almost as if it were a tool itself. Imagine a writer agent drafting a report and directly pinging a researcher agent to verify a specific historical fact before continuing. Second, we have directed acyclic graph, or DAG pipelines. These are rigid, predefined sequences. Think of it kind of like a factory assembly line, where step A absolutely must finish before step B can even start. It's perfect when you know exactly what steps need to happen every single time. And third, LLM-driven supervisor routing. This is where a manager agent dynamically analyzes a really complex, ambiguous task and routes subtasks out to the most appropriate worker agents on the fly. It's exactly like a human manager assessing a brand new project and delegating the pieces to the right people.
Section 4. Frameworks and performance trade-offs, management styles, and execution speed.
Just like in the physical world, how you organize and manage your AI workforce directly impacts how fast and effectively they can actually perform their jobs. Let's break down a few of the leading frameworks. LangGraph uses a shared state paradigm. It acts like a strict state machine, which offers incredibly high control and deterministic logic. Everyone knows exactly where they are in the process. Crew AI, on the other hand, relies on message passing. This is highly conversational, making it incredibly flexible for human-like collaboration. But think about human meetings for a second. They take up a lot of time. Message passing requires the AI to read, write, and interpret lots of messages back and forth, which creates heavy cognitive overhead. Finally, AutoGPT uses an artifact-centric shared memory, focusing heavily on deep autonomy, where agents continuously plan, self-correct, and adjust based on central files they all have access to. And this brilliantly illustrates the fundamental differences in how these systems manage their shared context.
Let's ground this hype in some hard data. When we look at throughput for tasks per minute, LangGraph leads the pack, hitting 42 tasks per minute. Why? Because its shared state machine removes the burden of figuring out what to do next from the LLM. The strict framework itself just handles the flow. Crew AI hits 34 tasks per minute because that conversational message passing we just talked about requires heavy processing time for the AI to constantly parse intent. And AutoGPT sits at 28 tasks per minute because that deep, autonomous goal-seeking behavior requires constant, time-consuming self-reflection and central planning. The real trade-off you need to take away from this is pretty clear. High control yields high execution speed, while deep autonomy trades that speed for flexibility.
Section 5. Securing autonomous AI agents. HR and compliance for the AI workforce.
Okay, we really need a serious tone shift here, because as we start giving these systems genuine autonomy, memory, and powerful tools, the real-world risks scale up exponentially. The Messaging, Malware, and Mobile Anti-Abuse Working Group submitted a pretty chilling comment to NIST recently. They said, prompt injection is the new SQL injection. Let that sink in for a moment. Natural language makes the attack surface practically infinite. Any text input coming from the outside world into your agent, whether it's an email, a scraped website, or an uploaded document, is potentially a malicious command actively trying to hijack your digital employee and use its tools against you.
And the threat goes way beyond just tricking an agent in the heat of the moment. Adversaries can actually inject malicious data directly into an agent's runtime memory stores. Remember those vector databases we built as semantic filing cabinets? If an attacker poisons that well, it fundamentally alters the agent's behavior in real time, indefinitely. Data poisoning isn't just a headache for model training anymore. It is an active, persistent threat to your agent's live working memory. So, how do we defend the workforce? We absolutely must build with a presume breach mentality. This means deploying some non-negotiable security guardrails. We need strict sandboxing, meaning agents operate in heavily constrained environments where they physically cannot access core system files. We must enforce the principle of least privilege, meaning agents only have the exact API keys they need for a specific task and absolutely nothing more. We need to use cryptographically signed model artifacts so you know with mathematical certainty that nobody has tampered with your digital employee's code before it boots up. And crucially, we must implement human-in-the-loop emergency shutoffs. We need robust technical circuit breakers ready to pull the plug if an agent goes rogue.
All of this leaves us with one final, vital question for you to consider. Are your enterprise systems truly ready to balance the immense power of agentic autonomy with the rigorous, mandatory security it demands? We have the frameworks, we have the memory architecture, and we have the multi-agent patterns to build totally incredible digital workforces today. The potential is absolutely staggering, but deploying them safely, that is the true test of enterprise readiness. Thank you so much for joining me on this explainer. Keep learning, keep building, and I will see you next time.